Okay, we are going through the signal design process, which has 3 steps. The first one was discussed on Sunday, which is developing the phasing plan, and we just discussed some guidelines because there is no fixed phasing plan. There is no method to come up with a single phasing plan to fit all the signals. The second step was calculating the timings of the signal, which includes yellow, all red. Then we need to know the volumes as well, for which we will design the loss time, the cycle length, and calculating the green, the effective green. Okay, so this is where we ended yesterday, the calculation of effective green. Okay, so today we are going to move on to the third step, which is checking for the pedestrian timings, or checking for the pedestrian safety. Okay, so first of all, you need to know how much time is required by the pedestrians to cross. Okay, obviously you have a signal at the intersection. Okay, so if the pedestrians are supposed to cross, they will cross when they find the signal green for them, right? Green for them means red for the cars, others, Indians. So first of all, we should know how much time they actually need, and then you will check if we are giving them that much time or not. So that time is calculated as, or is given as GP. Okay, GP means the pedestrian required green time. Okay, the time required by the pedestrians to cross. It has 2 parts here. You can see PW minimum and PC. Okay, PW minimum means minimum walking time for the pedestrians. Minimum walking time for the pedestrians. Okay, for that we have some standards. Okay, so you can see a table here. If you look into some other book, you may find different other values as well. Okay, but the minimum time is taken usually from the standards. Okay, so it depends upon in which area your signal is and how much is your cycle length. Okay, certain areas have more pedestrians, right? Like commercial areas have more pedestrians, school areas have more pedestrians. Okay, so in those cases the timing is higher. Okay, and similarly, if the cycle length is higher, the pedestrian timing is also higher. Clear? Okay, so you can pick a value from this table or any other standard for the first part, PW minimum walking time of the pedestrian. The second one is PC, which means pedestrian clearance time. Okay, pedestrian clearance time. Okay, what was clearance time? All right, huh? And it was for who? No. Which vehicles? Who is clearing what? The vehicles in the intersection. Pedestrian clearance time also means the same thing. Pedestrians who are already on the road. Pedestrians who are already on the road. So for them to clear the road, they already started crossing. Now they are on the road. So this PC is for them to clear the road. Okay. Now for clearance of vehicles we give all red. Pedestrian clearance, when the signal is about to close for the pedestrians, not the vehicles. So it was green. Now it's about to close. What does it do before closing for the pedestrian? The pedestrian signals. Flashing. Okay. So this is the flashing time basically. PC is the flashing time. So somebody is already crossing and the signal starts to flash for them. You know, pedestrian signals are facing them. So it starts to flash. That means it's about to get close. Okay. So what do you do as a pedestrian? Run. Yes. Good. So how do we calculate this? This is calculated using this. Okay. Length of the crosswalk divided by speed of the pedestrian. Length of the crosswalk divided by speed of the pedestrian. speed of the pedestrian is between 3.5 feet per second. Okay, speed of the pedestrian is taken as between 3 to 3.5 feet per second. And length of the crosswalk means what? From where do I get the length of the crosswalk? Width of the road. Okay, so for every road it will be different. So the first step is find out the time required by the pedestrians. Two parts. The first part from the standard, the second part calculated using distance upon speed. Okay, clear till now? Okay, then you need to check if this much time is available on the signal. GP, is it available on the signal? So he needs, for example, GP is 15 seconds. So he needs 15 seconds. Is 15 seconds available for him according to the timing you have designed? Okay. So for example, if I am going in this way, I am crossing in this way towards east. Okay. So with which signal I will cross? This one? Should I cross with this signal? If I am going in this way, should I cross with this signal? North, south? Huh? So the signal which is parallel to me, right? So if I am going towards east, I want the signal which is towards east to be green for me, right? Clear? So the timing of that signal should be at least that much which I need. Got it? GP should be at least equal to the time of the signal with which I will cross. Okay? Now, you have three options for checking. Three criteria. Okay? For checking. The first criteria is the time required by the pedestrian is at least equal to green plus yellow plus all red. Okay? So when this side has green or yellow or all red, adding them together, this is equal to the time which is required by me or more. Okay? So I can cross in this much time. Got it? Okay? So this is the first option I have. Because after the all red, what will happen? Some other side will become green, right? And that side may be conflicting with me. That side could be this one. So then I cannot cross, right? Okay. I have to cross it in this much time. The time I am providing is at least this much. Okay. Got it? The next option is that the pedestrian time is at least equal to green and yellow only. Okay. So I have the chance to cross, or I am calculating, I am assuming the pedestrian will either cross during green or yellow this much time. Okay, he doesn't need more than this time. Okay, clear? This is another option. After yellow, what do I have? All red, right? Okay, now all red means what? The other side is still doesn't open, right? The other side still didn't open. Okay, so for example, you made some mistake here. You made a mistake in calculating this time or this time. Okay, so even with the mistake, you have some extra time available, right? There is some margin of error for you here. There was no margin of error here, right? Because after this, the next side will start. But here, still there is a margin. Okay, so maybe you didn't think about a pedestrian on the wheelchair. He is slower, so he needs more time. Okay, but you didn't think about it, and you designed the signal for normal pedestrians. Okay, maybe that person on the wheelchair needs 1 extra second. So even with your mistake, he has 1 extra second of order. Got it? Okay. And the third option is what? I assume the pedestrian time is just equal to the green time. Okay. So after the green, what will I have? After the green we have yellow, and after yellow we have all red. So now I have what? Margin of safety is high. Okay. So even if you are wrong by 2-3 seconds, the pedestrian may still be safe. Clear? Okay. all these options, technically there's no problem with that. But the margin of safety is increasing when you go from option 1 to option 3. Okay. So the first step, find out time required by the pedestrian. Second step, check if the time is available or not. Okay. Third step, we will see its calculations using this example. Okay. So the third step is, if the time is not available, adjust the signal time. Okay. If the time which is required by the pedestrian is not available, adjust the signal time. In this example, we have two phase signals, phases A and B. For each phase, you can see the green time, the yellow time, the all red time, and the lost time. Okay. And for each phase, the pedestrians who will cross in that phase, their required time is given. Okay. So pedestrian who will cross in phase A, their required time is how much? 20. And those who will cross in phase B, their required time is 30. Okay. We are going with this option. Okay. Remember, capital Y is yellow and all red both. Capital Y means yellow and all red both. So we are going with the first option. The first option was pedestrian time should be at least equal to green, yellow and all red combined. Green, yellow and all red. Okay, no margin of safety. Okay, clear? Okay. Now look at the pedestrian time required for phase A is 20 seconds, right? And how much green, yellow and all red for phase A is? 45 seconds, right? So pedestrian needs 20, phase A has 45 seconds. No problem, right? Look at phase B. The pedestrian required time is how much?
20.
Huh?
20.
Like how can two people sitting in different locations be wrong at the same time? Huh? Mystery, right? Okay. So it needs how much? 30 seconds. Okay. And how much is the green, yellow and all red for phase B? 20 seconds. So now we have a problem, right? Phase B is not satisfying the criteria. Okay. So first thing is, I will find out how much time I should be giving for phase B. Okay. I want this to be at least equal to, right? At least equal to G plus small y plus, right? Okay. For phase B, GP is 30. And I'm saying this should be at least equal to G. Now yellow I know, right? Okay. G plus Y plus AR. Okay. For phase B, it should be at least equal to this much. Okay, so I have 3 times here, G, Y and AR. Okay, and I'm going to change which time to meet this criteria? We already know it's not meeting the criteria, right? Right now it is not meeting the criteria. It is only 20 seconds and the pedestrian requirement is 30 seconds. Okay, so presently it doesn't meet the criteria. Okay, so this should be equal to these 3 values. Summation of these 3 values. Out of these 3 values, which one can I change? Green. Okay, yellow and all red we don't change. They have separate calculations, they have equations for that. Okay, so we don't change them. Okay, they depend upon something else, not traffic. So we don't touch them, we just change the green time. Okay, so yellow, sorry?
How did we know that green is the one that can be edited?
Because I already calculated yellow and all red. We have equations for them.
Okay.
Yellow and all red doesn't depend upon traffic, depends upon the design of the intersection. We cannot change it. Okay, so yellow and all red I already know, 3 and 2 seconds, right? Okay, so 3 and 2, this one is 30. So how much is green time for B? Okay, so the initial green time is 15 seconds. It should be changed to 25 seconds to meet the pedestrian requirement. Clear? Okay. Now if we just change the green time of B, so increasing the green time of B, right? We are increasing the green time of B. That means you are decreasing the time for all other, which is what? In this case only A. Okay. Now we cannot do this. because the green time of A was calculated for its traffic. If you're increasing the green time of B, it doesn't mean the traffic of A will come into B. It's a different site, right? Okay, so you cannot just take time from one phase and add it in the other. Okay, so if you want to increase the green time of B, you have to increase from the overall as well. You have to increase the total time as well. Okay, so A traffic still has enough time for it. Clear? Okay, so I have to increase the total time as well. Otherwise, the extra time of B will be taken from A, which I cannot do. Okay, so I have to increase the total time as well. Okay, now for that, first of all, I'll calculate how much total time I have. Okay, so the old cycle length. Old cycle length is summation of the phases. Okay, we have two phases, right? Okay, a phase is green plus yellow plus all red. So I will take phase A. Remember, I'm calculating the old time, so I'm using the old phase of B. How much is this? 65 seconds. So the old cycle length is 65 seconds. Okay. For calculating the new cycle length, I need the effective green time of each phase. These values, 40 and 15, green values, these are the actual green times when the light will be green. Okay. Effective green time is green plus yellow plus all red minus lost time. Okay, so give me the effective green for A and B. Again, we are still talking about the old values, the values which you already see in the table. Okay, so how much is the effective green for A? 40 plus 3 plus 2 minus 5? 40. Okay, and for B it will be 15 seconds. Okay, this is how we got it. Clear? So I know the old effective green times, I know the old cycle length. Okay, now first of all I will calculate the new cycle length. Okay, the new cycle length. Okay, so the new cycle length is the old one, 65. Multiplied by, now I am changing the cycle length because of what? Which phase? Phase B, right? Okay. So the old time of phase B was 15. And I'm changing into what? 25. Sorry, it will be the other way around. 25. 50. So cycle length will increase by the same amount as you are increasing the timing of B. The total time will increase by the same proportion. So how much is the new cycle length? 108 point something 3. Okay, and we round off the cycle length to the nearest 5 or 10 seconds. In this case, it will be 110 seconds. Okay, now I will calculate the total effective green. Which is cycle length minus total lost time. Okay, cycle length is 110. Total lost time is total of the two phases. How much? 100. Okay. Now I will divide this 100 into the two phases. Okay, I will divide this 100 into the two phases. Okay, but to divide it in what proportion? Should I divide them equally? No, because the signals, the phases were not equal, right? Okay, so I will divide it with the same proportion in which the old cycle length was divided. Okay, so I will for example, if I'm doing it for A, okay, so I will take the total time multiply by the old proportion of the phases. The old proportion was phase A was 40. Now this is effective green, remember. 40 of the effective green. In this case, both are same, but I'm talking about the effective green now. Divide by 40 plus 15. 14? 40, sorry. Okay, so the new cycle length will be divided into phases using the same ratio what it was. This was a ratio of 65, right? And the cycle length was 65. Where is it? The cycle length is 65. This is the ratio, right? Between the phases. So I'm dividing the 100 with the same ratio as well. Okay. So how much is it for A?
61.5.
61. Sure.
72.7.
Yes. Okay. Now there are only two phases. So for phase B, you can just simply subtract it. How much is it? Okay, clear? Now from these are what? Which greens? Effective greens. Okay, so we can back calculate the actual green as well. Okay, using the same equation, which is this one. Okay, but as we know, yellow and all red time are not changing. Loss time is not changing. This is 2, this is 3, this is 2, this is -5. So that means what?
0.
Yeah, so this equals to this. Okay, so this is effective green as well as actually, but you need to keep in mind there are two different things. They may not be same always.
What's effective green? Effective green.
Phase time minus loss time.
But in actuality.
In actuality, it is the total time of the movement. Some of it is lost.
Pedestrian.
No, lost means nobody is using it.
Effective green.
Effective green is when you subtract the lost time. Okay, so this is the actual time of the phase which is used, in which people were entering. Okay, so this becomes then GB, and this becomes then GA. Clear? Okay. So we had the phase time, we had the pedestrian time, we checked the criteria. It was not meeting for one of the phases, so I needed to change. I cannot change one phase alone. Okay, it has to have an impact on the other phases and the total time as well. Okay, otherwise then you will have a problem with the other phases. So first of all, I calculated the old cycle length, summation of the phases. Then I calculated the effective green times, which is the phase minus the loss time. Okay. Then I calculated the new cycle length, okay, which was the old one multiplied by the ratio of the timings you want to change. Okay, the new time and the old time. So the new cycle length was this much. I calculated total effective green by subtracting the total loss time. Okay, and then the total time was divided using the same ratio in which the initial cycle length was divided. Okay, clear? Okay. Any questions? Okay. Now we are moving towards the revision of some of the topics which we have already done in the highway course. Okay. So what you will see here is a summary. Okay, you have or you are supposed to have covered these topics in more details in the highway course. Okay, so this is from chapter 3 of the current textbook. And we start with the the components of our traffic system. So our traffic system operates on 5 components, or it is affected by 5 components. The first component is what? The first component is V, right? All of us. We are the road users. So they may involve people who are in the vehicles, such as drivers and passengers. Driving or not driving doesn't matter. They are in the vehicle, they are part of the road users. Or they could be outside the vehicle, like pedestrians or bicyclists, right? Okay. And then we have the vehicles. Vehicles, we have earlier divided them into heavy vehicles and cars, right? This is another classification of vehicles according to their use. We can have private vehicles or commercial vehicles. Private vehicles are those which are used by for personal purposes. Okay, like which vehicle do we use? The cars, right? Okay, and then we have the commercial vehicles. Okay, which are used by multiple users at the same time, or used for commercial reasons, such as buses and what other vehicle? Trucks. Okay, trucks are also commercial, right? Okay, and which other vehicle is commercial but smaller in size? Taxis. Taxis are also called as semi-private. Okay, because most of the times they are hired by one person and so on. So they are private, but they're called semi-private. And then we have the streets and highways, all physical objects included. Then we have the traffic control devices, the topic which we just finished. What are traffic control devices? Signals, markings, okay. Anything which you put on the road to control the movement, right? Okay. Then we have the general environment. So anything which is part of, or which is affecting the roads, which are affecting the traffic, but it is not part of the first 4 elements, such as what affects traffic other than them? Rain, snow, okay, and anything else? Fog. Anything else which doesn't happen in Bahrain? Dust storm. See, old people giving local examples, right? Yes. Direct sunlight. Okay. Light conditions. Okay. Any even roadside objects, buildings, signboards. Not the signboards of traffic, like the other good signboards, which tell you where to go, where is the offer, right? What? No? Okay. So the most important, obviously, we are designing the traffic system to serve the users, right? They are the clients, okay? They are the ones for which we are designing, or we are doing all these things. So road users, the problem with them is they are not at the same level. All road users don't have the same characteristics, they don't have the same properties, okay? So they are different in terms of education, experience, okay, abilities, okay? Some of them are faster, some of them are slower, some they have disabilities, some are perfectly fine, and so on and so forth. Okay, so they have very wide range of characteristics. Okay, so we need to consider this into our design as well. So we never design for the average value. We design for which value? 85th percentile. Why do we go for 85th percentile? Why not average? We don't even know what is percentile, right? But we know what is average, right?
Because it takes the large range of the...
Because it takes a large range of data. That's why, yes. But then what is percentile? Yeah, it's not percentage. If it's a percentage, we call it percentage, right?
Percentage of the percentage.
Percentage of the?
Percentage.
Very good.
Range of the data.
Range of the data, yes. So when you say 85th percentile, you are covering 85% range of the data, okay? And if you are looking for the highest value, then we take 85th percentile. If you are looking for the lowest value, then we take 15th percentile. Okay, when the highest value is more critical, we take 85th percentile of the data. When the lowest value is more critical, we take 15th percentile of the data. Okay, so we talked about 85th percentile of what? Speed, right? Speed of vehicles, yes, obviously. Drivers are slow, we know that, right? But we take 15 percentile of who now?
Cars.
Come on.
Speed.
Speed of what?
Vehicles.
No, 15 percentile of vehicle. Vehicle speed. What will we do with all of that? Pedestrians. Pedestrians. Now the drivers. Yes. When they are outside the car. Okay. So for pedestrian, the critical one is the slowest one, right? For the, in terms of vehicles or cars, the critical one is the fastest one. So then we take the higher range, 85th percentile. For pedestrians, we know the critical one is the one which is slower. Okay, the one who comes after everybody in the class. That one. Okay. Then we take the 15th percentile. Okay. Till now, we have the drivers as the most important road users because they control the vehicles and they are the ones who are basically determining the demand as well. Till now, okay. We are fed up with them, so we are trying to get rid of them. Okay. So people are inventing new cars and so on. So once we have them, then you can easily sleep in your car, not in the class. Okay. So, but till now we need a good understanding of the driver characteristics to make the system work. Okay. So what is our job with respect to the drivers? We have to provide them information in a clear and effective way so they can do a safe and proper response. They can act safely and properly. Okay, and how do we do this? By providing what? I mentioned it already in the previous slide, it was mentioned. Signals is what? What did we call it? What did we call all these things? Signals, signs, markings? Traffic control devices. So this is a function of traffic control devices, providing information to the driver. Okay, and if you go back to the topic of traffic control devices, you will see them, the same or almost the same words there as well as the requirements of the device. Okay, the device should be clear, it should be positioned in a way so that the driver can see it clearly, and you should give him enough time to respond and so on. So all these things were mentioned. So this point is covered by traffic control devices. Okay, there are two characteristics of the devices, there are two characteristics of the drivers which are taken into the design of the system, which are visual acuity and reaction process. Visual acuity deals with the ability of vision, ability to see, and reaction process deals with the ability to think, the decision making process, the reaction process of the human being. Okay, so these two processes, looking at anything and thinking about it, they overlap. Okay, so when you look at something, your mind starts to think about it. Okay, like you start looking at me and then you start thinking, when will he go, right? When will he finish? Something like this. Okay. But these are the two processes we are talking about. Okay. If you have deficiency in any one of the abilities, then you will not get the action which you are looking for. Okay. The action will not be safe or proper. Okay. So for example, if you have a problem with the vision, the driver didn't see it properly, in the end, maybe his decision process is fast and he is thinking properly, no problem. Okay. But if he didn't see it, if he didn't know what is happening, then obviously whatever he will do will be abrupt. Okay, it will be sudden. Okay, so his action may not be proper, it may not be safe. And similarly, he is looking, but his mind is somewhere else. Why did I get low marks in exam 1 and so on? Right? Something thinking like this. So obviously then the action again will not be proper. Yes.
This is perception reaction time.
This is measured by perception reaction time. Yes. Clear? So these two abilities work. They should work in simultaneously, to have the safe and proper response. There are other abilities of the drivers, other characteristics of the drivers, which affect the driving behavior, such as personality and psychology. Personality deals with the personal characteristics of the driver. Okay, age, gender, education, experience. Okay, height, weight, whatever, ability, disabilities. These are all part of the personality of the driver. Clear? And psychology is related to the mental condition of the driver at the time of driving. Okay, someone is tired, someone is thinking about something else, okay, or they are scared of something, they got shocked because of something, okay, they did not sleep well. All these things come under psychology. Okay, and these things do affect the driving behavior, obviously. Okay, these things affect the driving behavior, but the problem with these things is we cannot quantify, we cannot measure them. Okay, you cannot represent them with a number. Okay, so there is no scale which measures these things and gives you a number, and then you can take this number in your calculations. Careful, when you're designing, you're doing calculation, right? Calculations, you need numbers. These things don't have numbers. Okay, so how do we make sure that drivers who are in different conditions and different characteristics, they are behaving in the same way on the road? Okay, so we do it by using traffic laws. Okay, that's why we have the traffic laws. So it doesn't matter you are in a hurry or not. The signal is closed, you are supposed to stop. Okay, I want to go this way, but you have to follow the direction. Okay, so traffic laws are there to make sure that whatever your condition is, you are going in the same way as all the other drivers. Okay, and that way is what the authorities feel that this is a safe way. Okay, clear? And how do you know about traffic laws? When do you know about traffic laws? You have to do this and then this and then this. This means this. Huh? No, like you see the device, how do you know this is what it means? So when do they give you this knowledge? When you get the license. Okay? The licensing procedure tells you what are the laws, and then you follow them while you are driving. So this is how drivers from different characteristics behave in the same manner on the road. Going back to the two characteristics which we take into design, we have, why are you doing this? Too much condition. See? They are part of you. You never complain when you are using them, right? Huh?
I know.
You know, right? I do not teach it. Anyways. So we have visual characteristics, okay? The functions which our eyes perform while we are driving, okay? Alhamdulillah, all these functions, what you are doing, this, okay? They are even like you are sitting here and all these things are being done, okay? By us, because even without us knowing about it. So you can see the name and you can see the example where do you use it on the road. So for example, accommodation. Accommodation means changing focus for looking at different objects. Okay, so when you are taking pictures, your camera have autofocus in them, right? But they take some, maybe half a second to focus when you change the angle or when you change the distance. It takes some time to do the autofocus, otherwise the image will be blurred. Okay, same thing happens with your eyes, much faster. You don't feel that my eyes are adjusting the focus, right? It's not like I'm looking at him and it's blurred and then it becomes clear. There's nothing like this, right? So that is used obviously by your eyes when you are looking at the things inside the car and then outside the car. So it's a big change. And your eyes do autofocus, accommodation. Then we have static visual acuity. They do a test before they give you the license, right? Not the driving test. Before they give you the learning license, they do a test. Which test? Vision test, right? Okay, the eye test. That is the static visual acuity. So they ask you to read different letters and numbers. Okay, so The same thing is required when you are reading the traffic signs. Okay. Then we have adaptation. Adaptation means adapting to different changes in lights. Adapting to changes in lights. Okay. So you may be coming out from a garage which is completely covered, no lights, and then you come outside during daylight, bright daylight. Okay, so your eyes need some, or they do adjustment to light as well. Same thing happens when you're going inside a tunnel, then you're coming out, going inside under a bridge and coming out. Then we have angular movement. Angular movement means looking at objects which are across our field of view. Okay, and it's not only looking. When you look at something, your mind is processing how far is it, how fast is it, and so on and so forth. How fast I am going. So all these things are processed. So angular movement is used when you are judging the vehicle's speed which are crossing you. So you're waiting on the roundabout. You look at the vehicle is crossing. So how fast is it? After how much time I will get the chance to move. So this is angular movement. Then we have movement in depth, which is adjusting to the varying size of the object according to its distance. Okay, when something is getting closer to you, its size is increasing. Okay, because of the distance. Okay, so it's increasing. So your eyes tell you how far that object is based upon the size. Okay, and obviously based upon the change in size, then you can measure the speed as well. You can get an idea about the speed as well. Then the ability to differentiate between different colors, and it helps you obviously at the signals. You have to see the colors, right? Okay. And then we have the contrast sensitivity, which is the ability to differentiate between colors which are one over the other. Okay. So you see there's a background color and there's a foreground color, right? Okay. Now this is blue and white, so very easy. Black and white, very easy. Okay. But if I use, for example, red and blue, not so easy, right? Okay. But sometimes we have these type of situations on the road in front of us. Okay. For example, a pedestrian walking at night using dark color clothes. Okay. So this happens. So your eyes needs to adjust to this contrast as well. They need to detect that there is something, not just like. Okay. And then we have depth perception. So we have depth movement depth, and depth perception, both. Depth perception is a judging of the distance. Judging the distance. So movement in depth was judging the speed, and depth perception is judging the distance. Okay, but both of them for the same type of objects which are coming towards you. Okay, so judging their speed is called movement in depth. Judging the distance is called depth perception. Okay, then we have dynamic visual acuity. So we talk about static visual acuity, right? Which was what? What was static visual acuity?
To see small details.
To see something, right? To see something in static position. This is to read something or to see something in dynamic. Okay, because we have both while we are driving. And then we have the eye movement. Okay, so without changing your line of sight, your eyes can move, right? And some people can do it different ways as well.
Little.
Huh?
Little.
No, some people do it like this.
Yeah, little.
Huh? It's not little, they go like this.
Yeah, little. Come here.
You did. Okay, so anyway, so this is called as eye movement. Okay, so this eye movement helps you to look at the entire screen or the entire scene in front of you without moving your head. Okay, so this is what you do. You are looking at your window screen. Okay, but your eyes move from right to left. So you are not changing the head movement. You are not doing any head movement, but your eyes still are able to see from side to side. Okay, then we have glare sensitivity. Glare sensitivity is related to adaptation. Okay, so when you have extreme light in your eyes. Okay, for example, headlight, a car coming from the other direction, and it has very bright headlights on. Okay, so it comes directly in your eyes, and this needs some adjustment. Okay, so when you initially have the light in front of you, suddenly you don't see anything, but after maybe 1 or 2 seconds your eyes adjust. So that is called glare sensitivity. Then we have peripheral vision. Peripheral vision is to see the objects which are on the side of your field of vision. Okay, so even if I'm looking at you, I can see my hands. Okay, if I hold something in my hand, I can see it. Okay, so this is called peripheral vision. Then we have vergence, which is the changing of angle for different objects which you are looking at. Okay, for example, changing from looking at the dashboard to the road, so it's a different angle, right? Dashboard is much lower, road is much higher. Okay, so this changing angle is called as vergence. So all these different abilities are used, and you can see the examples how and where they are used on the road while you are driving. Clear? Any questions? Okay.